and welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be doing part 2 of our lesson on polygons. Let's get started. So I just thought it would be a good idea to take a look at this kind of a flow chart. It might help with a review of what we learned in our last lesson. So in the world of quadrilaterals, we have irregular quadrilaterals, as we see here. We have parallelograms, which we talked about in our last video, and we have trapezoids, which we also talked about in our last video. In parallelograms, we have rectangles, squares, and rhombi, plural for rhombus. All right, so let's also look at some types of polygons. So remember, a polygon is a closed figure, and I'll highlight this because it's important to remember, made up of lines and angles. And we can classify polygons by the number of sides and angles they have. Here are some of the regular polygons that you'll see on an ongoing basis pretty regularly. Triangle, 3 sides, quadrilateral, 4 sides, pentagon, 5, and so on and so forth, all the way on up to a decagon, which has 10 sides. Also over here on this list, I've written down the sums of the interior angles of these shapes or of these polygons, these regular polygons. So we talked about in one of our previous lessons that the interior angles of a triangle will always total 180. And we also mentioned that the interior angles of a quadrilateral will always equal 360. And so here we have pentagon 540, hexagon 720 degrees, and so on and so forth, all the way up to a decagon, which is 1,440 degrees, if we were to add together all of its internal angles. Also important to note, polygons can be either regular or irregular. Let's take a look at that. Regular polygons have congruent sides and angles, as you can see here in this regular pentagon, whereas irregular polygons do not have congruent sides and angles. Pretty simple. All right, let's take another look at these regular polygons below. And we'll just read each of these little sections. So let's look at the first blue piece of information here. Okay, regular hexagon, right here. It has 6 congruent sides and angles. Now remember what we had on the slide a couple of minutes ago. The sum of a hexagon's angles is always going to equal 720 degrees. Because the 6 angles are congruent, they are all 720 divided by 6, 120 degrees. So basically, you just take what you know to be the sum of what all the interior angles will be, which is 720, divide it by the number of angles that the shape has, in this case, 6. 720 divided by 6 equals 120 degrees. Let's try it with an octagon. A regular octagon has 8 congruent sides and angles. The sum of an octagon's angles is always 1,080 degrees because the 8 angles are congruent, so they have to be the same all the way around. All 8 of them have to be the exact same number. You simply take 1,080, divide it by 8, and you can find out the measurement of each one of those 8 angles, which is 135 degrees. Pretty interesting, and actually pretty easy too. Okay, now don't feel intimidated when you look at this next graphic. It's not as bad as it looks, I promise. It looks a little scary, but it's actually super fun once we figure out how to break it into pieces. So now we can use what we know about polygons to analyze them and their relationships. Do you see any polygons in the diagram below? You can pause the video if you need to. Take a look hard, and see if you see any polygons in this picture. All right, did you find them? There are a few. One of the largest polygons in this figure is AMDE. AMDE, okay? And within that one, there are within AMDE, there's 2 more figures. There's ABCDE, kind of looks like a house, like a side of a house, A, B, C, D, E. And also there's a triangle. Did you find the triangle? M, B, and C. There's a triangle right here. So we have 2 shapes within that one big shape. Okay, So figure ABCD is a polygon with 5 angles and 5 sides. Remember, A to B, C, D, okay? E. That is a pentagon. And 2 of its angles we know are going to measure 90 degrees because you see this little blue box here, right? So 90 and 90, that's helpful. And when we're given the measure of 120 degrees, that's also helpful. So we want to find what are the measures of these other 2 angles, right here next to the B and the C, inside that little house shape. How could we find out the measurements of those 2 angles? Well, what we probably should do is look at the third figure, MBC, first. So let's do that. So we know MBC is a triangle, and we know that triangles' angles must total 180 degrees, right? The angles we do know are both 60 degrees in this triangle. 60 and 60. Well, 60 plus 60 is 120. And if a triangle's interior angles have to add up to 180, we would just have to subtract 120 from 180 to know that this angle is also going to be 60 degrees. Knowing that all 3 angles are congruent tells us that this is an equilateral triangle. They all have the same measurements. Okay, so that would be the measure of the unknown angle in MBC. Now angles ABC and MBC are supplementary and will total 180 degrees. So what that tells me is if I want to know what this measurement is here, this top of the little house in figure ABCDE at the top, it is supplementary. It is actually adjacent to this 60 degrees. I know it has to total 180, so I take 180 because it's a straight line. 180 degrees minus 60 degrees tells me that that little angle will be, actually big because it's obtuse, 120 degrees. All right, so I've put that 120 degrees there now. Okay, so a pentagon's angle measurements, if you paid attention on the back screen or if you happen to write it down, the interior measurements of a pentagon's angles need to total 540 degrees. So now we have 4 out of the 5 measurements of the angles that we need. So we just need to set up an equation to try to find the number of the measurement of that last angle. So we'll do 90 plus 90, because we got 90 here, 90 here, 120 and 120, one here and one here, and angle BCD right here, we don't know what this is, equals 540 degrees. So 430, which is all these numbers added together, plus angle BCD equals 540 degrees. Subtract 430 from both sides, and we find out that BCD equals 120 degrees. See, it wasn't so hard. It was actually kind of fun. All right, everyone, I hope you enjoyed this lesson on polygons. Thanks so much for joining us, and we'll see you next time. Bye-bye.